Hello everyone, welcome back to my channel. If you are new to my channel, please consider subscribing my channel. And in previous session, we have talked about what is the front end VLSA and what is the back end VLSA. So, and also we have discussed that in front end, what are the courses that we need to learn in order to enter into the front end field. So, in this, so those are two main important languages. One is Verilog HDL and the second one is System Verilog. Okay, so today we are going to see like what are HDLs actually. So HDL is the full form of hardware description language. Okay, so HDLs are nothing but it is the programming language, nothing but for example, if you are going to take a AND gate. Okay, you all know about in digital electronics, you all know about basic gates and AND gate, OR gate, NAND gate, right? So when you are going to take one simple AND gate, and this AND gate is a physical, like for this AND gate you are going to write a program, you are going to write this hardware description for this AND gate. Okay, so that means that is called as HDL. So HDL is basically is a programming language which is used to describe the structure, behavior and timing of the electronic circuit that you are using. Okay, that means whatever circuit that you are designing, that entire circuit that you are going to design, you are putting that entire circuit in the coding format. In simple language, we will call the HDR as a textual writing of the hardware. Okay, simply that means whatever hardware that you are going to design, for that entire hardware you are writing a program for that entire hardware. That means when you are going to write a when you are going to write a program, when you are writing a HDL for AND gate, then this HDL is similar to that of the physical form of the AND gate. Okay, hope you understand about what is HDL. So this is hardware description language. So when coming to the HDS, so basically we will call it as a programming language, but in in reality it is somewhat different from that of programming language. So basically you learn different programming languages like C, CPP, Java and all. So these are all programming languages, and we will utilize this programming language in order to create a software. That means we are creating the software by using the languages like C, CPP and all. But when you are coming to this hardware description language, from the name itself you are, can say that you are describing the hardware by using this language. That is why we call this Verilog and System Verilog as HDLs, not a programming language. Okay, so HDL is nothing but you are writing the hardware, you are writing the code for the hardware. Okay, got my point. So this is about HDL, and basically HDLs will be serving the purpose of simulating the circuit and verifying its response. That means why, what is the use of this HDLs? Basically when you are having the physical form of circuit, like you are having the hardware portion, you can't simply put everything. You can't have, if you want to have any changes in that, you can't easily convert the hardware, you can't easily make the changes in the physical form of the hardware. But when it comes to coding, you can do it much more easily. So that is why before going into the hardware, you are going to write a coding for that hardware, and then you are going to convert this into hardware. Okay, so basically in present field, like in present scenario, there are many HDL. So basically for you, in order to enter into the VLSL, like the real time industries, basically they will be asking you about mostly two languages. One is two most popular HDLs, we can call it as, one is Verilog and the second one is VHDL. Okay, 90% goes for Verilog, because basically VHDL is also a HDL language, but mostly 90% of the industries, that means whatever language that we are going to learn, that should be useful for us, is it or not? When you go into the real time, and what is the thing that you are learning, if you are going to apply that into the real time field, then it will be useful for this. If it is not useful for us, then what is the use of learning a language? What is the use of wasting our entire time on that language, and if you don't have any opportunities on that particular language, is it or not? So basically, that is the thing here. Mostly in today's present mm, electronics like VLSI field, most of them are asking for Verilog. Okay, because why this Verilog is more popular than coming to that of VHDL, we'll be going to learn. Okay, and then the second one is Verilog VHDL. So basically, these two are most popular HDLs. One is Verilog and the second one is VHDL. Okay, so generally, as I already told you, HDL is nothing but a hardware description language. So why do we use them? We use them for designing various processors, motherboards, CPUs. So everything, every electronic, every chip that you are going to design, mostly you will be designing by utilizing this HDLs, hardware description languages, right? So coming to what are the advantages of this HDLs? So first and most important thing is reusability. So what is this reusability? Basically, uh, we can call this reusability. For example, if you are writing, if you are, as I already told you in the previous thing, like you can have the flexibility in order to make any changes, and you can use the remaining. For example, if you have written some code for particular design, okay, and you want to insert some more, you want to add some more features for your particular design. So for that reuse that for so that when you want to add some features for your particular design, you can use the remaining code as it is, and you can add the remaining features to that with the help of this reusability technique. Did you get my point? So reusability is nothing but using the entire code, and with this you will also be adding somewhat features like for that. So that comes under reusability. And then flexibility is nothing but any, you can change anything very easily. Like as I already told you before, when it comes to physical format, like physical form of the chip, you can't really um, change it as easily as when it comes to coding. Okay, so that comes under flexibility. That means you have a flexible in order to change or modify the designs. And then coming to lower cost. So since since you are just using the like programming language is nothing but, since you will be just using some code, you'll be writing some code, and also you don't really need much cost compared to that of the cost that goes into the hardware section. So that is why, coming compared to the hardware, like compared to the hardware design of the chip, it is much more lower cost. And then coming to better simulation is nothing but, as we already discussed in the previous sessions, nothing but after designing the code, you will be simulating that. Okay, so since it is the code that you are simulating, so you can easily find the bugs, and when after your simulation is done on the particular thing, you can easily find if you have any bugs, if you can easily catch the errors, and you can improve your design so that there won't be any problem during the fabrication process. Because as I already told you, fabrication means it involves much more cost compared to that of the software, is it or not? So that is why, if you have done any mistakes during the fabrication process, it really costs much, right? So in order to avoid that, what we are doing a HDL. That means we are designing our particular IC in the software, and if we observe any bugs, we will be removing that, and we can easily design our chip. Okay, so these are the advantages of HDLs. So coming to Verilog, as I already told you, Verilog is the mostly used HDL in present scenario. So coming to when and where this Verilog was introduced and all, so it was developed in 1980 by Gateway Design Automation, and then in 1990 it was acquired by Cadence. So presently we are having 2001 IEEE updated Verilog LRM. Okay, so this is the evolution of Verilog. That means when and where it was introduced and all. And then coming to what is Verilog. Okay, so Verilog is nothing but it is verification and logic. Okay, it's a combination of two words like very log, verification, logic. That means we are verifying the logic. That's it. Okay, so this is the hardware description language. And one important thing in Verilog is this is case sensitive. Case sensitive language means it's all the keywords should be in the lower case. And since most of the engineering students know about C, is it or not? So again, one more important thing why Verilog is used by many of the industries, and why it is so important is the one important thing about Verilog which makes it easily understandable. Its syntaxes are mostly similar to C, but I don't say that those who doesn't know C can't get into this industry, or can't understand Verilog. But if you are having a basic knowledge on C, you can easily understand this Verilog. Okay, and then it's very easy to learn. That is why I told you, like, if syntaxes are mostly similar to C, that is why it is very easy to learn and use. And by using this Verilog, we will be using for modeling the digital systems. Okay, we will be using various abstraction levels in this Verilog, like gate level, switch level, okay, behavioral level and all. Okay, we'll be seeing that in the next sessions. So this is about what is Verilog, and what is HDL, what is among them, what is Verilog, and what are the advantages in the Verilog, right? So this is all for today's session, and we'll be continuing the next session tomorrow. If you like this channel, please subscribe this, and if you are having any doubts, please pin them in the comment box.